Welcome to our journey into the fascinating world of melting. Have you ever wondered why ice turns into water or how metals are shaped into useful objects? Melting is a process that surrounds us every day, from the ice cubes in your drink to the wax in a burning candle. In this video, we'll explore what melting really is, why it happens, and how it impacts our lives in surprising ways. So let's dive in and discover the science and wonders behind melting, starting with the basics and moving into some amazing real-life examples. Melting is a physical process where a solid turns into a liquid when heat is applied. This transformation occurs at a specific temperature known as the melting point. For example, ice melts at 0 degrees C, turning into water. The process involves the particles in a solid gaining energy and moving more freely, which breaks the rigid structure of the solid. Understanding melting helps us grasp how materials behave under different conditions and why certain substances change their state when heated. The molecular level, melting is all about energy. When a solid is heated, its molecules vibrate faster as they absorb energy. Eventually, they move so much that the forces holding them together break down and the solid becomes a liquid. This is why adding heat to ice causes it to melt into water. The process is reversible too. If you remove heat, the liquid can freeze back into a solid. This basic principle is key to understanding many natural and industrial processes. Melting isn't just a scientific concept, it's something we see every day. Think about butter softening on warm toast, chocolate melting in your hand, or snow disappearing on a sunny day. Each of these examples shows how heat changes the state of a substance. Melting plays a role in cooking, weather, and even art. It's a reminder that science is always at work, even in the simplest moments of our lives. Let's take a closer look at one of the most common examples of melting: ice. When you take ice out of the freezer and leave it at room temperature, it slowly turns into water. This happens because the heat from the air transfers to the ice, causing its molecules to move faster and break free from their solid structure. Watching ice melt is a simple way to see the science of melting in action. Not all substances melt at the same temperature. For example, ice melts at 0 degrees C, but iron melts at a scorching 538 degrees C. The melting point depends on the strength of the bonds between the molecules in a solid. Substances with strong bonds, like metals, require more heat to melt. This diversity in melting points is crucial in industries like metalworking and food production, where precise temperature control is essential. Reason substances melt is rooted in physics. When a solid is heated, its particles vibrate more vigorously. Eventually, the energy becomes strong enough to overcome the forces holding the particles together. At this point, the solid loses its shape and becomes a liquid. This process is essential for many natural cycles and technological processes, from the water cycle to metal casting. Melting and freezing are opposite processes. While melting turns a solid into a liquid, freezing does the reverse. Both processes occur at the same temperature for a given substance. For example, water freezes and melts at 0 degrees C. This relationship is important in understanding how materials behave in different environments and is key to many natural phenomena, like the formation of ice in winter. Nature is full of melting processes. Snow and ice melt in the spring, feeding rivers and lakes. Glaciers slowly melt over time, shaping landscapes and affecting sea levels. Even volcanic lava is an example of rock melting deep within the earth. These natural melting events play a vital role in shaping our planet and supporting life. Melting is a key part of the water cycle. When snow and ice melt, they release water that flows into rivers, lakes, and oceans. This process is essential for replenishing freshwater supplies and supporting ecosystems. Without melting, many regions would struggle to get the water they need for plants, animals, and people. Cooking often involves melting. Think about melting butter in a pan, cheese on a pizza, or chocolate for a dessert. Understanding how and when ingredients melt helps cooks create delicious dishes. Melting can change the texture, flavor, and appearance of food, making it a crucial part of culinary arts. Chocolate is a perfect example of melting in action. When you hold a piece of chocolate, the heat from your hand causes it to melt. This is because chocolate has a relatively low melting point, just below body temperature. That's why it melts so smoothly in your mouth, creating a rich and creamy texture that we all love. In industry, melting metals is a powerful process. Metals like iron, aluminum, and gold are heated to high temperatures until they melt. This allows them to be shaped, molded, or combined with other metals to create alloys. Melting metals is essential for making everything from cars to jewelry, showing how this process drives innovation and manufacturing. Recycling often relies on melting. Old metal cans, plastic bottles, and glass jars are collected and heated until they melt. The melted material can then be reshaped into new products, reducing waste and saving resources. Melting is a key step in turning trash into treasure and supporting a more sustainable world. Candles are another everyday example of melting. When you light a candle, the heat from the flame melts the wax near the wick. This liquid wax is drawn up the wick and burned, producing light and heat. Watching a candle burn is a simple way to see melting and combustion working together. Artists often use melting in their work. Sculptors melt metals to cast statues, while painters might melt wax for encaustic art. Even glassblowers rely on melting to shape beautiful pieces. Melting allows artists to transform raw materials into creative masterpieces, blending science and imagination. Melting is at the heart of many climate change discussions. Rising global temperatures are causing glaciers and polar ice caps to melt faster than ever before. This contributes to rising sea levels and changes in weather patterns. Understanding melting helps us see the impact of climate change and the importance of taking action. When large amounts of ice melt, the water flows into the oceans, raising sea levels. This can lead to flooding in coastal areas and threaten habitats for both people and wildlife. Monitoring melting rates is crucial for predicting and managing the effects of climate change on our world. Melting ice and snow can also affect weather patterns. As more ice melts, less sunlight is reflected back into space, causing the Earth to absorb more heat. This can lead to warmer temperatures and changes in rainfall, storms, and other weather events. Melting is a key factor in understanding our changing climate. Melting requires energy, usually in the form of heat. In industry, huge amounts of energy are used to melt metals, glass, and plastics. Finding ways to make melting more efficient can save resources and reduce pollution. Scientists and engineers are always looking for new technologies to improve melting processes. Innovations in melting technology have changed the world. From ancient blacksmiths melting iron to modern 3D printers using melted plastic, advances in melting have enabled new inventions and industries. Melting is at the heart of progress, allowing us to create, build, and imagine new possibilities. Melting can be dangerous if not handled properly. High temperatures, hot liquids, and molten materials can cause burns or fires. That's why safety equipment and procedures are essential in places where melting occurs, like factories, kitchens, and laboratories. Understanding the risks helps keep people safe. Materials scientists study how different substances melt and how their properties change during melting. This knowledge helps in designing new materials with specific melting points for various applications, from electronics to aerospace. Understanding melting is key to creating stronger, lighter, and more efficient materials. Melting is one of several phase changes that matter can undergo. Others include freezing, evaporation, and condensation. Each phase change involves energy and changes in the arrangement of particles. Understanding these changes helps us control and use materials in everyday life and industry. Alloys are mixtures of metals created by melting and combining different elements. For example, bronze is made by melting copper and tin together. Alloys often have unique properties like increased strength or resistance to corrosion, making them valuable in construction, transportation, and technology. Glass is made by melting sand and other minerals at very high temperatures. The molten mixture is shaped and cooled to form windows, bottles, and art. Glassmaking is an ancient craft that relies on precise control of melting and cooling to create beautiful and useful objects. Plastics are often melted and molded into products like bottles, toys, and packaging. The ability to melt and reshape plastics makes them incredibly versatile. However, plastic waste is a major environmental issue, so recycling and responsible use are important. Electronics manufacturing often involves melting metals like solder to connect components. The precise control of melting points ensures reliable connections and performance. Advances in melting technology have enabled smaller, faster, and more powerful electronic devices. Jewelry makers melt precious metals like gold and silver to create beautiful pieces. The molten metal is poured into molds and shaped into rings, necklaces, and more. Melting allows for intricate designs and customization, making each piece unique. Construction relies on melting for materials like steel and glass. Skyscrapers, bridges, and homes are built using materials shaped by melting and molding. Advances in melting technology have made construction faster, safer, and more efficient. Transportation systems, from cars to airplanes, depend on materials created by melting and shaping metals and plastics. Lightweight alloys and strong glass are essential for safety and performance. Melting technology continues to drive innovation in how we move around the world. Spacecraft and satellites are built using materials that withstand extreme temperatures, including melting and freezing. Engineers carefully select metals and ceramics with the right melting points to ensure safety and performance in space. Melting technology helps us reach for the stars. Medical devices and tools are often made by melting and molding plastics and metals. This allows for precise shapes and sterile equipment. Advances in melting technology have improved healthcare by enabling safer, more effective medical tools and implants. Some energy storage systems use materials that melt and solidify to store and release heat. These phase change materials are used in solar power, heating, and cooling systems. Melting technology helps make energy use more efficient and sustainable. Freezing and melting are important in food preservation. Frozen foods are kept solid to prevent spoilage but must be melted or thawed before eating. Understanding melting helps ensure food safety and quality from farm to table. Melting can play a role in disaster response. For example, rapid snowmelt can cause floods, while melting infrastructure during fires or heat waves can create hazards. Understanding melting helps emergency planners prepare for and respond to natural disasters. Sports like ice skating, skiing, and snowboarding depend on the properties of ice and snow. Melting can affect the quality of the surface and the safety of athletes. Maintaining the right temperature is crucial for competitions and recreation. Fashion designers sometimes use melting techniques to create unique fabrics and textures. Heat can be used to melt and bond synthetic fibers, resulting in innovative clothing designs. Melting brings creativity and technology together in the world of fashion. Special effects in movies and theater often use melting materials to create dramatic scenes like melting wax figures or simulated lava flows. Melting adds realism and excitement to entertainment, captivating audiences with its visual impact. Teachers use melting experiments to help students understand science concepts. Simple activities like melting ice or chocolate make learning fun and memorable. Melting is a great way to spark curiosity and inspire future scientists. Many cultures have traditions involving melting, such as pouring molten metal to tell fortunes or melting wax for holiday decorations. These customs connect science with culture, showing how melting has been part of human life for centuries. Modern artists experiment with melting materials to create new forms and textures. From melted plastic sculptures to wax paintings, melting opens up endless creative possibilities. Art and science come together in these innovative works. Looking ahead, melting will continue to play a vital role in technology, industry, and daily life. New materials, cleaner energy, and advanced manufacturing all depend on our understanding of melting. The future holds exciting possibilities as we learn more about this fundamental process. We've explored the many sides of melting, from the science behind it to its impact on our world. Melting is more than just a change of state, it's a process that shapes nature, industry, art, and our everyday lives. By understanding melting, we gain insight into the forces that drive change all around us. Thank you for joining us on this journey through the wonders of melting. From ice cubes to skyscrapers, melting is a process that connects science, art, and everyday life. As we continue to explore and innovate, melting will remain at the heart of discovery and progress. Stay curious and keep exploring the amazing world around you.